Good morning, afternoon, and evening, ladies and gentlemen of the world, and welcome to the Elipsis & Co. Tutoring channel, where today we will be continuing with the numbers topic in the IGCSE Maths syllabus. In this video, we will be talking about sets in the language of mathematics. So without further ado, let's begin. Now sets are the official language of maths. We obviously know that words can get long and repetitive, so mathematicians usually use signs and notations. For example, the most used notation is the equals sign, which means that the left-hand side is the same as the right-hand side. Similarly, sets use the same idea. In this topic, there are 10 notations that we need to learn. But before we get into them, we need to understand what a set is. A set is just simply a collection of objects or values. These objects in a set are called elements. The first notation is the most common set, which is called the universal set. Also known as the mother set, this set is a collection of every single element within a given region. Typically, the mother set is just every integer. So we would write that the universal set is equal to open bracket 1, 2, 3, 4, 5, up to infinity, close bracket. These brackets that we use are called curly brackets, or braces. The second notation is called the element of sign, and it's in the shape of an E. This notation shows that any element within the braces is an element of a particular set. For example, if we say set C represent numbers between 1 and 10, we can write this as C is an element of 1, 2, 3, 4, all the way up to 10. Next, we have a similar notation to the previous one, and it's called the not an element of sign. This notation is just the previous set with a line across. Simply put, this shape shows that any element within the braces is not an element of the set. For example, if set P represents all prime numbers, we could say that P is not an element of 1, 9, and 20. Similarly to the previous notation, there are also what is known as complements of sets. This notation represents what is not in a particular set. This notation usually differs from the previous one when we are considering closed universal sets. For example, if we were to say the universal set is all numbers between 1 and 100 and set A is all even numbers, then the complement of set A, indicated by an A, is any number that is not in set A, which would be odd numbers. Furthermore, we have what is known as an empty set. This is any set that is empty, indicated by a line over a zero or an empty brace. An example of this would be a set like set Q, which contains a 3-digit number between 10 and 20. Because there are no 3-digit numbers between 10 and 20, set Q would be empty. The sixth notation is a bit different from every other notation. In this notation, rather than listing all the elements, this sign lists the number of elements in the set. This is indicated by an N, and the set in between the brackets. For example, in a set which contains even numbers between 1 and 100, the number of elements in this set would be 50. Now, the final 4 notations differ from the last 6 as they represent a pair of sets. The first being a union of 2 sets. A union set is simply the combination of 2 sets, indicated by a U shape. For example, if set A has elements 1 and 2 and set B has elements 3 and 4, then the union of A and B is 1, 2, 3, and 4. Next is an intersection of 2 sets. Normally, when considering 2 sets, there can usually be similar elements which are found in both sets. For example, if considering a mother set of numbers between 1 and 10, and if set G is prime numbers and set J is even numbers, the elements intersecting these 2 sets will be 2. The final 2 sets are contrary to each other, the first being the subset of sets. A subset is a set found within another set. Like we saw earlier in this series, natural numbers can be considered a set inside of the integers numbers set, as natural only represent positive integers. The second notation is not a subset of sets. This simply means that a particular set is not a subset of another set. Now, all these notations might seem like a lot to grasp at first. To combat this, mathematicians use what is known as a Venn diagram. A Venn diagram is one comprised of circles inside of a square. The square represents the mother set, and the circles represent different sets. Typically, Venn diagrams are made of 2 intersecting circles. which show that the two sets are intersecting. Alternatively, Venn diagrams where the two sets do not intersect are called mutually exclusive events. This means that these two sets or events cannot happen at the same time. For example, if we consider set H, which represents apples, and set R represents oranges, then these two sets will not have intersections, and therefore are mutually exclusive. What if we had a mother set of numbers ranging from 1 to 20? If we had set A, which consisted of prime numbers, and set B, which consisted of odd numbers, how could we draw this on a Venn diagram? Well, firstly, we would write all the numbers out. We know that prime numbers within this region are 2, 3, 5, 7, 11, 13, 17, and 19. Conversely, odd numbers would be 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. After that, the next step is to find any repeated numbers. These would be 3, 5, 7, 11, 13, 17, and 19. Put these numbers in the intersection. The remaining group numbers will fall in the outer regions of the circles. All the other numbers which do not fall in either of the groups all lie in the outer parts of the rectangle, outside the circles. These numbers are 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now, let's say we had a class of 28 students, and they had a choice of 2 subjects to choose from. If we know that 10 of them choose history, 16 of them choose maths, and 5 of them choose both, how could that be drawn on a Venn diagram? This might be a little more tedious from the last one, but the method used is the same. Firstly, we start with the intersection. We know that 5 students choose both subjects, so we can write this down. Next, let's focus on history. Off the 10 people, we know that 5 of them also do maths. This is because even though the 5 is an intersection, it is also part of the history set, so therefore, the people who do only history is 10 minus 5, which is 5. Similarly with maths, we say 16 minus 5 is equal to 11 people who just do only maths. Finally, we need to find out which students do neither subject. From our data, we can find that 5 people do history, 11 people do maths, and 5 people do both. This means that in total, 21 people do either maths or history. Therefore, only 7 people do neither subject and lie outside of the circles.